These are the directions for the student investigation evidence of oxygen worksheet. Now you have to do a few things. Essentially, we're going to compare the atmosphere of the past to what it is today, like we already did in class. But we're going to look at some evidence to figure out why it changed into that. The first thing you're going to do is read this background that I wrote. These are the big highlights of what was going on in the past and now and how those things happen. Next, you're going to analyze this graph. This graph is different than any other graph you've probably ever seen. It's called an area chart. It's like a pie chart, but it's like many pie charts over time, all put into one graph. What do I mean by that? What I mean is, if you've ever seen a pie chart, let's just look at any old pie chart. Here we go. It shows you the parts of a whole. So if we're talking about like the atmosphere, when you look at one pie chart, it'll tell you that this much of the atmosphere is made of this gas, this much of the atmosphere is made of this gas, and this much is made of this gas. Now, the only problem with one pie chart is that it only shows you one period of time. So this could be 1999, or 3,000 years ago, or a billion years ago. But what we want to do is we want to look at the atmosphere and the composition of the atmosphere over all these times. So every single space on here, if we pick like 4 billion years ago, that essentially is showing you a pie chart of what gases were in the atmosphere at that time. Notice the graph all goes up to 100% of the atmosphere. So each color represents how much percent that gas takes or made up of the atmosphere at that time. Okay? So I'm going to help you with this. Let's say we're going to 3.5 billion years ago. I know that's not perfectly straight, but this is just for an example. So if I wanted you to tell me, well, what are the percentages of each gas in the atmosphere 3.5 billion years ago? First, what you do is start at the bottom. The gray is carbon dioxide, obviously from the key. At 3.5 years, it ends here. So that's somewhere between 0 and 20. To me, it looks a little less than half. Or I could just make this easy. Let's say it looks like half. I would say that looks like, for carbon dioxide, I'd say it's about 10% of the atmosphere. All right. Now, this big blue part, that's nitrogen. So you might initially think, all right, at 3.5 billion years ago, there is 60% of the atmosphere was nitrogen. But remember, it's like a pie chart. This down here, this carbon dioxide is 10%. So between 10 and about 60, that would be nitrogen. So what you have to do is you have to do a little bit of subtracting. So nitrogen is from 60% minus the 10% from the CO2. So it's about 50% of the atmosphere is nitrogen. See, we're starting at 10, going up to 60. So from 10% up to 60 would be 50. And then for the red, that looks like a tiny bit. I would just say that's about 3%. So that would be hydrogen. About 3%. Typing is terrible. And now if we look from hydrogen, starts about right here. So we're at about 63 up to the top, up to 100%. That's going to be other. That doesn't mean that the atmosphere is 100% just because this goes up to 100. It means that it's from 63 up to 100. So we have to do that little bit of subtraction. %, minus the 63. About 37%. Now obviously oxygen, if we look, at that time period there was none. Right, let's look at it right here. Yeah, there's no green in this space here. So 3.5 billion years ago, there was 10% CO2 in the atmosphere, 50% nitrogen, 3% hydrogen, 37% other stuff. When we add those together, we should get 100%, which we do. 10 plus 50 is 60, 63, 60 plus 30 is 90, and 7 plus the 3 would be 100%. That's how that works. Now, if you look at a different time period, let's say 1 billion years ago, right here, that's like another pie chart. We have about less than 1% CO2. We have like 70% nitrogen. Between here from 70 up to like 80, let's say 10. And then the rest is probably like 20%. That's how this works. Now, the only other thing you have to do with this, which is sort of straightforward, you're going to answer these questions, but then down at this, you're just going to match up and literally write it on this paper. Right, I'll move this down a little bit so there's space on your paper. All you're going to do is take your pen, and it says that the origin of the Earth was 4.5 billion years ago. Just draw a line here, boom, and write origin of the Earth. I'm not going to write it all out because I'm using my trackpad. And then what you're going to do is you're going to go to another date. Photosynthesis evolves in plants. You're going to find where that correlates with the graph right here, 3. Put photosynthesis evolves in plants. So essentially what's going to happen is after you read this and you analyze this graph, you'll have a better understanding of why the Earth's atmosphere changed its composition. You'll understand where all the CO2 went, how the nitrogen built up, and where all of this oxygen came from. If you have any questions, just ask.